Welcome everyone back. I hope you're not so boring about this course. So, today we will introduce about the 2-qubit separate quantum circuit. Okay, this is kind of very interesting part. For example, you have a 2 kind of qubit. This kind of separate. So if each one qubit can run and run around, this kind of independent. So that's kind of interesting part, in photon or the qubit in the quantum or the qubits, the quantum sphere or Q sphere. So, but how to represent in the mathematics and how to simulate that case. So today I will introduce how to do that. Okay, to simulate how 2 qubit separate each other, we can have one of this kind of code to tell you can you register 2 qubit and insert it to a circuit and try to initialize and visualize in a matplotlib. Yeah, and you see over here we can have the important part. Yeah, we can insert the quantum register. Yeah, and we insert these 2 qubit, and after we have a 2 qubits, we can create a quantum circuit. So when we create the 2 circuit Q1 and Q1 Q0 and Q1, and after we have a circuit, we can add the initialize the value by the Hadamard, the gate. So this one from the first. Yeah. So this is a result. So after you can you create the 2 qubit and insert to the quantum circuit, you can see 2 lines, Q1 Q0 with the Hadamard gate, and Q1 is have no value over here. So but this figure can tell you, okay, this kind of 2 bits is separate each other. But in practice, how to know this kind of these 2 qubits separate each other? How to prove? So here is a detail, the computation, to prove how the qubits separate each other. So so we can calculate one by one. First time, remember we can compute the data for the quantum part based on the insert Hadamard. The first this part we have this part we can calculate we can calculate the tensor products for the first part. This is Hadamard and Q0, and tensor below is identity the matrix with the Q1. Okay, so remember if we have a 2 bits, so we have a total about 4 states. 4 states. For each one, we have, for example, Q0, we have 4 states: 0, 0, 1, 1, right? Or 1, actually, it's 0, 0, or 0, 1, or 1, 0, or 1, 1. Yes, that is a total 4 state. So after you combine together and you calculate a tensor product, for each kind of qubit value. For example, compute the tensor products for the qubit 0 and qubit 0. So you can get a result for each one, and after that you can you can make a total, something like this. You can calculate by the in parallel. For example, you can calculate tensor products for the qubit 0, or you can move to the matrix. Move to the matrix, something like that. So if you see in this kind of the computation, you can see we can calculate this kind of 2 matrix first. And we can calculate this one first and this one later, and that's after we can combine this one and this one. So here is the result for this part, for the first part, and this is a result for the second part, and this is a result after you make the the compute the tensor products for the state vector. So the result after you compute the 2-qubit tensor state vector, and you can see this kind of result, or based on the single unitary operator, you can calculate about this one first and this one later, and after you combine this one together, and this is a result. So you see the result for the final part is similar my previous one. If you see, we have okay. So if you see this one is result is similar. Yes, it's a result for this part, and previous one is similar. Yes, from this one is similar. So that is a compute for 2-qubit separate the quantum circuit. So now is one example. We can add a circuit for or this one is one more. One more. We can add one the gate for the qubit 1, and we will see. Yeah, you will see previous one do not have this kind of Hadamard gate, right? And now we add more Hadamard gate for the Q1, and you can see the detailed computation after you can you add this one is a new. Yes, a new. This one is different from the first one because you have a Hadamard gate. So follow the same the previous one. You can calculate tensor products for two kind of state vector, and 8Q1 calculate the tensor products with 8Q0, and we can have a follow the same method from previous one. We have 2 qubits, so we can have a total 4 positive agent state. So 0, 0, 0, 1, 1, 0, and 1, 1. So we can compute tensor product. And so the tensor products for this kind of vector and calculate, so that follow the previous example. So this kind of final result. So over here, this one is very important. You can calculate about this one first and this one second, and after you can combine. Each one will have a result for this part, and this part have a result, and you can make tensor products. Tensor products for this kind of to the matrix, and this have final result. And here was similar. If you use a single unitary mode, have a same kind of result. Same kind of result. Same kind of result. So F very important. Now you can split. You split the final result to the two parts, and can make tensor products two vectors together. So it means the output can be decomposed to the part. So decompose to these two parts with tensor products. So that means we can separate. The X part can separate. Can separate in a two qubit state. So this one is the fundamental how you can make sure the qubit, this one qubit independent when it's run around a sphere, or this one can run around, so and never met each other. So that's going to separate. If someone is a kind of something like this, and can have the bit can make a collapse, so that is a kind of in separate. So we can we will look more detail that part later. But today the most important thing, I want to summary. We'll try to simulate how the two qubits can separate each other, and try to prove how that kind of separate can be in the mathematics the model. Okay, thank you everyone.